Hi, this is Stephen Brower from Irvine Community College. This is for CSIT 256, Computer Architecture and Assembly Language. And this is going to be part one. I don't know how many parts are going to be. It's going to be part one of Irvine Chapter 4. Just like I did for Chapter 3, when I'm done with all the videos, the final demo file I'll load up into Canvas for a reference. So one of the things we're going to be taking a look at in this chapter is the MOV, MOVZX, and MOVSX statements. Now for the demo I'm about to do, it's a little bit silly, but I created just some 8-bit variables. So I have the number of months since January. I know it's silly, but it's an unsigned 8-bit variable. It'll never be big. Countries, I misspelled, countries visited, and I'm putting that as 180. And this is an unsigned byte. And 180, that's, appropriate for the number of countries. So that's, I'll leave that as is. And just for the purposes of this, because of the demo I'm going to do later, I have a signed byte, arguments won lost, meaning I've lost more arguments than I've won. You got a problem with that? Sorry. Okay, so the thing about the move statement, it's going to add a comment here. So move must have like bits, or I should say same number of bits. And so what would happen is, if I say move EAX, comma, and I'll be lazy about it, the number of months since January. And so I want to load that into EAX. So load EAX with number of months since January. And sorry, this it should not compile. So if I try to do a compile, okay, instruction operands must be the same size. Line 25. So line 25. The issue is EAX is 32 bits, and this variable is 8 bits. So it's not letting me do that. So let me just, I'm going to comment this out. So I'm going to say invalid. Can't move 8 into 32. Can't move 8 bits into 32 bits using move. All right. And I'm leaving that behind as a comment because I'm sort of changing the demo. But I can move, I'll do here, let's do AL. I should be able to, this should compile. So the 8-bit variable can go into an 8-bit register. Now since I didn't clear out the rest of EAX, there is the potential, yep, there you go. So the lower part right here, 06, that's what I loaded, the number of months since January. But since I didn't clear out the upper piece, then the EAX at this point has stuff above it. And so if I went and did something with EAX, I wouldn't have 6. I have, that's a hell of a lot bigger than 6. Okay. So the downside of this, okay, so let me do this way. Downside is that the upper 24 bits are not cleared out. Okay, so MOV, we need a like number of bits. If we want to, instead of doing a separate command to clear out EAX and then loading this, if we wanted to in a single statement load it, and clear the upper bits, that's where we can do MOV ZX. And because number of months since January is unsigned, then what it would do is make those upper bits all 0. So hopefully this would, sorry, I forgot to change that. I was so busy copying. I did that deliberately to show the error. Yeah, that's it. That's the ticket. So now that I did that, the MOVZX, those upper bits have been cleared out. So in a single statement, we can clear out the upper bits, load in the data that we want, and this way, in terms of doing something smaller into something bigger, we can do something smaller into something bigger. Now, the issue is, so let's go on with this next one here. So countries visited. So suppose I take the that one would be well still let me do this way. If I do a move ZX into EBX, my countries visited. Countries visited. Oh, EBX. Can't talk and type. So let's load EBX with countries visited. Okay. Now that's up. I mean, that's fine. But what I do want to point out, though, and the main reason why I'm doing this, if we think of what B is in terms of binary, so the B in terms of binary, 10, 11. So that's 11. So 8, 4. Okay, that's B, and then 4. All right, so that is the binary number. I'm going somewhere with this. That's the binary number that was loaded in. And for any doubting Thomases, which is me right now because I'm not doing a good job on this. So if I put in this as the binary number, there's the hex. It is before. I did get it right. But as an 8-bit number, if you notice, the leftmost bit is 1. Now, for an unsigned number, that's fine. But I'm just pointing out that you know, it looks as if it's a negative number just from the. I'm sorry. Let me do this again. Whoops. Right. When you look at this thing as a whole, it's a positive number because there's a 0 in the leftmost position. Because that first 0 is 0, 0, 0, 0. It's a positive number. But if I look at just what is in BL, it looks as if it's negative because the leftmost bit is 1. And so I'm just doing that just more to point out that the unsigned numbers can look large. So now let me with CX. So, and I'm going to deliberately do this wrong. Okay, so hang on. So bad. Let me do MOVZX into ECX with arguments 1 lost. So load ECX with arguments 1 lost. Okay, now let's think about that. Negative 24, well, it is a negative number. But I'm doing an MOVZX. And the MOVZX is going to take the upper 24 bits and then set them to 0. So what this will do, when I look at ECX as a whole, it looks like a positive number. So because I did MOVZX, the upper bits were put in a 0, if I'm looking at ECX, the entire thing as being a number, I have the wrong value here. So the bad part about the MOVZX here is that we're not preserving the sign. Because if I am looking at this 32-bit number, there's a 0. Remember, this hex here is 4 bits, 0, 0, 0, 0. There's a 0 in the leftmost bit. So what move, and I'm going to comment this out. Okay, that was bad. What the proper thing to do for signed is to do MOVSX. And what that would do is that will preserve the sign. And what we should see is, well, remember the hex for 1111 is F. So the upper hex should all be F for this. And there it is. So the MOV, oh, geez, sorry. The MOVSX preserves the sign. So looking at this as a 32-bit number, there is a 1 in the leftmost position. So when you're taking something smaller and moving it into something bigger, you have to know what it is that you're moving. And the fact that I was able to do this, assembly didn't come back and say, hey, you're using ZX with a signed variable. Don't do that. It lets you do that. There's no error. So we have to be mindful. We have to be careful when we're dealing with our variables that we use them in the correct way. So the MOVZX here was fine because it was an unsigned number. The MOVSX was needed here because it was a signed number. Okay. I'm at 11 minutes. Let me pause for a second. The one thing that's going to stick in the front here for right now, which this will affect EAX. I just want to do this for giggles and grins. Let me increment. Oh, the case doesn't matter. I'm just used to when I do a demo screaming to the back of the room. Let me increment the number of months since January. So let's just pretend it's next month. And so I'm able to increment. That actually adds 1 to the variable that's there, the variable that I'm later loading here. So I should see on the dump that I should see a 7 in the leftmost thing because that was being loaded. So just pointing out that we can use the inc for adding 1 to a value. And the DEC is the same thing, but the other direction. So if we have a time machine and we go back to May, yeah, well, we could. What the hell? Let me comment this out. And let's do the same thing, but do a DEC and say, let's pretend it's the prior month. And so I should have a 5. If I'm only going to do the DEC, then 5 would be in EAX. Okay, so that's part 1. And I'm at 1340. Let me end that for part 1. So what I focused on here in part 1 of this video is, or this part 1 video, is focusing on the move, the MOVZX, the MOVSX, and then the inc and the DEC. And the difference of the MOVZX and the MOVSX has to do with whether we're dealing with signed or unsigned values. Okay, good enough.